What is the best computer to run local language models without everything feeling slow or unusable? It technically runs, but it feels unusable. This isn't a bug. It's a symptom of a much deeper problem. Your frustration has almost nothing to do with CPU clock speed or benchmark scores. If you're a builder, a founder, or anyone serious about AI, you've probably asked this question. What is the best computer to run local language models without everything feeling slow or unusable? If you want practical AI strategy and tips to grow your business, make sure you subscribe. The market is full of hype and confusing specs when it comes to AI hardware. Today, we're going to cut through all of that noise with a practical guide based on real-world daily use so you can actually choose the right hardware to run AI tools locally. You might already have an absolute beast of a machine, a top-of-the-line processor, tons of RAM, and yet, when you try to run an LLM, it feels sluggish, slow, laggy, and incredibly frustrating. The reason for this gap between a fast LLM experience and a slow one is the core mystery we're going to solve today. And I bet the answer isn't what you think. This should sound familiar. People hit a wall and say, it technically runs, but it feels unusable. The AI model loads. It doesn't crash, but trying to get any real work done is painful. You're waiting for tokens to generate. The whole system feels like it's groaning under the load. This isn't a bug. It's a symptom of a much deeper problem with how most people think about the best setup to run LLMs locally. Your frustration has almost nothing to do with CPU clock speed or benchmark scores. The real bottleneck holding your workflow back is memory. Not just how much memory you have, but how it's designed and how fast the model can access it. We've been trained for years to think compute is king when choosing hardware. But for large language models, that intuition is wrong. These models are overwhelmingly memory bandwidth bound. Once you understand this one concept, choosing the best computer to run local language models becomes much clearer. Let's give the problem a name: the memory spill. This is the moment your system runs out of its fastest memory, like GPU VRAM or unified memory, and is forced to juggle data with much slower system RAM or even your SSD. That's the cliff where performance drops off. That's what creates that unusable feeling when running AI tools locally. Now think about everything that has to fit into that fast memory at the same time. The model weights, the KV cache, which is the model's short-term memory for your conversation, temporary working space, and all the system processes running in the background. If all of that doesn't fit comfortably, you trigger a memory spill, and no amount of extra CPU power will save you. This leads to the most important question you should be asking when evaluating hardware to run AI tools. Where does the model actually live while it is thinking? Forget cores and gigahertz for a moment. What matters is where those billions of parameters physically reside while the model processes your request. Are they in fast memory right next to the processor? Or are they constantly being shuffled over a slow, crowded bridge? That answer changes everything about the best setup to run LLMs locally. So, if memory is the real problem, how do we get these massive models to fit in the first place? This brings us to the unsung hero of local AI: quantization. Without quantization, none of this would be happening on personal machines. Running local language models would still be locked away in massive data centers. A model's original file is like a raw photo, perfect quality, but massive and impractical. Quantization is like converting that raw file into a high-quality JPEG. You lose a tiny amount of numerical precision that you'll likely never notice. In exchange, the file size drops dramatically, making it possible to run models locally on consumer hardware. You don't need to be an expert here, but it helps to know the gold standard. Based on extensive testing across the community, Q4KM quantization consistently hits the sweet spot. It dramatically reduces memory requirements while preserving key abilities like reasoning and instruction following. That's why it's the default choice for many people building the best setup to run LLMs locally. This part is critical. It's far better to run a slightly smaller model that fits entirely in fast memory than a larger model that constantly triggers memory spills. If the model can't breathe, it doesn't matter how smart it looks on paper. Performance and consistency will suffer. Now that we've covered the why, let's talk about the what. Based on these principles, what hardware should you actually be looking at? Let's get practical and talk about the best computer to run local language models for a few common scenarios. First, the one laptop setup. You're coding, writing, giving demos, and traveling. You need your AI tools available wherever you go. Portability and integration matter. For this user, a MacBook Pro with an M-Series Max chip is currently the cleanest option. But the most important spec isn't the chip, it's unified memory. 64 gigabytes is the minimum. Apple's unified memory architecture allows the GPU to directly access all of that memory, removing the traditional VRAM bottleneck. For local AI, more memory beats a newer chip generation every single time. The second scenario is my own setup. You already have a laptop you love, but it struggles with local AI workloads because of VRAM limits or thermal constraints. Instead of replacing it, you separate the responsibilities. That leads to a dedicated Mac Studio, a small, quiet box that lives on your network with one job: to act as an always-on personal AI lab. This setup isn't about replacing your daily laptop. It's about augmenting it with specialized hardware to run AI tools efficiently. Here's why it works so well. 64 gigabytes or more of unified memory acts like one massive pool of VRAM. Data doesn't need to move between memory tiers. The cooling is designed for sustained workloads, so performance doesn't drop off. And because it's always on and accessible over the network, you can tap into its power from any machine without disrupting your workflow. This brings us to the ideal architecture for anyone serious about this work. It's not one machine. It's the best setup to run LLMs locally. Your laptop handles daily work and portability. The Mac Studio is your private AI workhorse for experimentation and development. The cloud is reserved for massive scale, production workloads, and occasional fine-tuning. When choosing the best computer to run local language models, your priority list should be clear. Number one, by a wide margin, is memory size and memory architecture. Number two is thermals, because overheating kills sustained performance. And a distant third is the specific chip generation. The goal of a great local AI setup isn't higher tokens per second. It's removing friction between an idea and execution. When your machine can instantly load a model and run smoothly and quietly, you stop thinking about hardware. You start thinking better. So ask yourself this: is your next hardware purchase about chasing numbers on a spec sheet, or about deliberately building the best setup to run LLMs locally so you can think, create, and build more effectively? That answer will guide you to the right choice.